All right, let's look at problem number 3, finding real roots by graphing. This is something that you're going to want to store away for a later date when we look at some of the later lessons in Chapter 5. This is going to come in handy quite a bit. Okay, so what I wanted to make you guys comfortable with here with these problems and why I assigned these problems is I wanted to get you comfortable using the graphing calculator. You've done this before when it comes to quadratics at finding zeros. All I'm asking you to do here is do it again. This time just do it with polynomial functions. What you always have to do, if you're going to use your graphing calculators that are there in class, make sure that you set the equation equal to 0. Okay, so those two guys right there, that 4x squared and that x, need to be moved over to the left side of the equal sign. See how they did that by subtracting 4x from both sides? And since that's positive x, we need to subtract x. You know what they did there? They wrote it in standard form. And then we can use the 0 features. If we were looking for those zeros, do you guys need to see this? Maybe you do. Maybe you do. And if you do, if you don't, sorry, I can't help it. I got to show cool tricks with the calculator. All right, so as you can see here, just typed it in already. X cubed minus 4x squared minus x plus 5. So set it equal to 0. That's clutch. Make sure you do that. Hit that graph button. There's that great looking cubic function just right there. So what we're going to do is we're going to make the graphing calculator get us those zeros. So just like you're seeing in that note sheet, here's how you do it. Press the second button. You know you've pressed it when you see the arrow. Press the trace button. We are looking for zeros, so number 2 makes sense to pick right there. And so systematically each one, doesn't look like I pressed the right button here. Let me try that again. Second trace, 0, 2. There we go. That's more like it. So it wants it pointed left. Let's find the leftmost 0 here. So let's arrow left, 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 left bound. Looks to be about probably -1, pretty close to -1. See my x right down here says -1.7. Make sure you just pick a number that's on the left side of where you think that is. Press enter. A little arrow pops up. Now it says right bound. Arrow to the right until you feel like you're to the right side of where that 0 is. I think I'm on the right side when I'm above the x-axis. So press enter again. Guess if there's only one 0 in that little set of arrows that you have right there. You really don't need to guess, but if you want to humor the calculator, go ahead. Press enter. There's that 0 right there, -1.09, so not precisely 0. Okay? All you got to do next is just repeat this for the other zeros. Left bound, enter, right bound, enter, enter. There's your other one. Repeat the process again for the next one. So when we go back to our note sheet, take a look at that. That's all they're really doing there. Okay? Take a look at this brain melter of a problem. Sorry about that. A lot of students can really get perplexed by this one. The reason why is because they aren't quite sure how to model consecutive integers. If I asked you guys right now, if I was there in front of you and I asked you, give me 3 consecutive integers, some of you first might ask me what consecutive means. Consecutive just means numbers in a row. So give me an example of consecutive integers, right? 4, 5, 6. Oh, great joke. Why was 6 afraid of 7? Huh? Huh? Because 7, 8, 9. Guess what? Those are consecutive integers. Okay? So, if I were to describe consecutive integers and any mystery consecutive integers, couldn't I describe them just like this? X. That'd be my first integer. Wouldn't the number after that be best described with x plus 1? Right? For example, if my integer was 4, the next one would be 5, 4 plus 1, right? And then the one after that would be 6. I could describe 6 by taking that same 4 but then adding 2. So there's 3 consecutive integers. So let's actually read the problem. What are 3 consecutive integers whose product, there's a product right there, and multiply them together, is, code word for equal sign, 480 more than, or more than, that means addition, then their sum. Their sum, wait, so you tell me I have to take x and now add x plus 1? Yuck. Oops. And then add x plus 2? Yucky. Okay? Let's do a little bit of simplification here, and then I'll show you how this is not so ugly. Okay? First, let's just worry about that right side. Okay? That right side, I got 480. When you're adding polynomials, don't overthink it. These parentheses really don't mean much, because inside the parentheses you can't do anything anyway, right? So I really have an x, a second x, and a third x. So don't I really have here 3x. And then if we look at the numbers that we got going on here, I got a 1 and I got a 2. So wouldn't that just be plus 2? I can clean this up even more. How about that? Write this as 3x plus 482. How you liking me now? Okay. How about this guy over here? Here's the unfortunate thing you're going to have to do. You're going to have to multiply these together. My foiling ninjas can take care of this, right? If we multiply all those first, outer, inner, last together, here comes x squared plus 3x plus 2, right? Distributed property. Now I have x to the third plus 3x squared plus 2x. Don't worry, we're almost there. They're asking for those 3 consecutive integers. By the way, you probably could have been guessing and checking a whole bunch of consecutive integers, but right now, we've taken the guessing and checking out of it. So, just like any polynomial function, boy, is this screaming at me. Set it equal to 0. So let's go ahead and do that. How about we subtract 3x? Let's subtract 482. Let's subtract, let's put it right here. 3x, and let's also subtract 482. Not like terms, right? So now I have x cubed plus 3x squared, 2x minus 3x, would put me at negative 1x, and then I have minus 482. Let's check that work. Okay, I'm doing this. It's like you're watching a rough draft right now. If I had a million hours in the world, I'd be doing this once just to make sure there were no mistakes, and then I'd probably do another take here. But let's just check my work. How is it looking? 2 minus 3, I think that's good. Yeah, looks good. Okay? Now, I got bummer alert news here. I don't think you're going to want to try to factor this one. In fact, I think if you try to factor it, you're going to be in some serious trouble. So, instead, how about we just graph this stinking thing and let us find that 0. If all goes well, that 0 should give us an integer, which is a number that's not a decimal. So, let's go ahead and type that in. Oh, wait, before I type it in, I found a mistake. I found it. That's why I do rough drafts, right here. Some of you might have been screaming if the sub was showing this during class. Shouldn't that be a 3? Yeah. So then shouldn't this be 483? Yeah. Okay. Sorry. 483. So then we're subtracting 483. So this would be 483. And now let's graph that guy. Double check. Okay. Yes, that looks much better. Okay, sorry about that. Let's go into the calculator now. All right, there you go. X cubed plus 3x squared minus x minus 483. Double check. All right, awesome. Good to go there. So let's graph this thing and pray we get an integer. Graph slash. Wow. There's a line right there. Let's confirm. Go to the table. Should be a positive number here. Scroll positive, positive, positive. Oh, please be 7. Ah, yes, it's 7. Look at that. So what the heck does that mean? Well, here's what that means. Our 0 is 7, right? So back to our problem. Oops, wrong page. Flip the page. There we go. What we just solved using a graphing calculator. Put that equal sign back in there. Where'd you go? There you go. We just used a graph to figure out that x equals 7. What does that mean? You just found the first of the 3 consecutive integers. Okay? So doesn't that mean the consecutive integers would be... Comes full circle. 7, 8, 9. Oh boy. Oh boy. I know. I promise I did not see that coming. Okay? Can we check our work? Sure, we could. Could we take 7 times 8 times 9? Right? Let's do that. The product is that 480, what was it, 480 more than their sum. So if I take 7 plus 8 plus 9, we get that. And then if I take 504 and subtract to find the difference, yes! Okay? I promise you, I give you 2 homework problems. They are not nearly this difficult to do. Okay? Not even close. Okay? So, there's that. Good luck on 5-3. Next one, synthetic division in 5-4.